folks, welcome to example 2. So we're going to take a look at a different type of system of nonlinear equations. This time we're going to go circle and line. All right, and much like the parabola and line, you can have no solutions if the line doesn't intersect the circle. You can have exactly one solution if the line is tangent to a point on the circle, or you could have two solutions where the line intersects the circle twice. So we're going to use the same thing, we're going to go through the same mechanics. We're going to use substitution. We're just going to have different looking equations. So let me scooch this up so we can get going. Okay. All right, let me kind of even that out. All right, so if I take a look at this, here's my nonlinear equation. And this is a circle, and depending on what you remember about circles, right? If you had x squared plus y squared equaling r squared, or actually let me even be a little bit more specific. All right, and what I mean by that is if I want to really get into the equation, we typically say x minus h squared plus y minus k quantity squared is r squared. And two properties we can read from this particular equation is that the center of my circle is at hk, and then my radius is just the number r. And if I was going to play that out for this particular equation, because these are just x squared and y squared, and it's not x minus 1, it's really x minus 0, right? It's not, I don't have something like this, x minus 1 squared, y minus 3 squared equaling 10. I just have x and y. So what happens is it's implied that the center is at 0, 0. Right, so if I really want to get fancy with this, and I don't know how worth it is to go down that rabbit hole, if I have x minus 0 squared plus y minus 0 squared equaling 10, for this particular problem, I can see my center is at the origin, and my radius is actually the square root of 10. All right, because square root of 10 squared is the number 10, right? This is r squared, so if I take the square root of that number, and by definition, I need to take the positive square root, not the negative square root, because radius is a distance, and that's going to be positive. There we go. All right, all that aside, I want to substitute. So I could solve this equation for x, solve this equation for y, solve this equation for x, or solve this equation for y, and plug that in to the equation I didn't solve for, if you will. And just looking at this, I think the easiest one for me to do is solve for this linear term where we just have x and no coefficient in front of it. So if I take a look at this line, right, if I solve for x here, I'm going to move the 3y over, right? So just so we're clear, this is a line, so I'm going to get x equaling 3y minus 10, because I'm going to add 3y to both sides, right? And just so we're keeping track, this was the circle. All right, the most I could do, or the most you might want to do, you could try and solve this for y if you wanted to, just so we could eventually graph it. And if we have time at the end, which I guess I can make time if I'm making the video, I'll go ahead and graph it and show it to you. Right? It's not going to be as simple as example 1, but we can still make it work. Okay, so I'm going to take x being 3y minus 10, and I'm going to substitute that in to the equation I didn't use yet. And then we're going to solve for y. All right, so let me put some separation here. All right, and we are starting with x squared plus y squared is 10. And instead of x, I'm now going to substitute in 3y plus 10. Excuse me, 3y minus 10. So I'm going to have 3y minus 10 squared plus y squared equals 10. All right, and I can't distribute that exponent over that binomial. So I am going to need to FOIL this out, or double distribute. So here we go. 3y times 3y is going to give me 9y squared. Outer and inner are both negative 30y. So I'll write that. I got negative 30y minus another 30y. Last is going to be plus 100. Don't forget I have this plus y squared still here, and that's all equal to 10. So I can combine some like terms here. I can combine the 9y squared and the y squared. I can combine the negative 30y and the negative 30y. And then I can subtract the 10 over. Right, so I can do all of that in the same step. So 9y squared and y squared is going to be 10y squared. negative 30y minus 30y, negative 60y. 100 minus 10, positive 90. That's equal to 0, right? So now I have a quadratic equation. Anytime you want to solve a quadratic equation, there are 3 ways to do it. Right? You can factor, you can use the quadratic formula, or you can complete the square. I'm going to try and factor this. And if you don't want to try and factor it, don't. Just go to just use the quadratic formula. But I can see there's a GCF, so I'm going to factor out the GCF of 10. So I have 10 times y squared minus 6y plus 9. And that is a perfect square trinomial. This is y minus 3, right, in parentheses, squared. So if I solve this a little bit more succinctly, let me move this up here so we've got it, right? I will have 10. This is y minus 3, right, equaling 0, right? Because outer, if we were to refoil this, outer is 3 times negative y, right? Negative 3y. Inner is negative 3y. Negative 3y minus another 3y is negative 6y. But I'll typically write it this way. And then I've got the 0 product property, right? 2 terms multiplying to 0. One of them must have been 0. 10 is a constant. It's never 0. But y minus 3 is 0 when y equals 3. So I now at least have the y coordinate of my solution. But I do need an ordered pair. So let's plug y being 3 back into my x equals equation. So if I want to get x, if I want to finish this problem out, x is going to be 3 times 3 minus 10, right? X is 3y minus 10. Well, if y is 3, and I do the math here, what do we got? 9 minus 10 is negative 1. So my overall solution is, we can do this, negative 1, 3. It's that ordered pair, okay? Now, just for fun, I am going to try and solve this on my calculator. I'm going to try and graph it, but I will tell you, when you try and graph circles on your calculator has like old school graphics. It's not as fancy as all those video games that are out there right now. So I'm going to try and confirm this is negative 1, 3, just algebraically, so we're all on the same page. If you really wanted to confirm it just algebraically without using your graphing calculator, you can plug x being negative 1 and y being 3 back into both of these equations and see if they hold true. Right? If x was negative 1 squared is 1. 3 squared, right? If y is 3, 3 squared is 9. 1 plus 9 is 10. That checked out, right? If I do negative 1 here for x, minus 3 times 3, well, negative 1 minus 9 is negative 10. That checked out. So there's an algebraic way to check, but let me talk about how I could graph this. Now, if you want to graph this, you need to solve both of these things for y. All right, so if I want to solve for y, let's make sure we have enough space here. So I'll take a look at x squared plus y squared equaling 10. And I'm also going to look at x minus 3y equaling negative 10. So if I ever want to plug these into the calculator, I have to solve them in terms of y equals. So here, I can move the x squared over, right? And then I can take the square root. So y would be either the positive or negative square root of 10 minus x squared. If you graph the positive square root, you're going to get the top half of a circle. If you graph the negative square root, you're going to get the bottom half. If I solve for y here, I'm going to add the 10 here, add the 3y here, so I would have x plus 10 equaling 3y. And then I'm going to divide everything by 3. All right, so that's how I'm going to opt to do that one. So let me go ahead and say y would equal, and I'll do x plus 10 over 3. And if I've solved everything for y, then I can enter these into my calculator. All right, that's the stipulation for your calculator, though. You have to be able to get them in terms of y equals to go ahead and plug them in. So let's see if I can get this to work, all right? So the first one I have is the positive square root of 10 minus x squared. Then I have the negative square root. Oops, that's not it. Let me go back to my y equals. And I have the negative square root of 10 minus x squared. And then I have, and I'll protect that binomial, x plus 10 divided by 3. So I'm going to graph all of this. Right? I'm putting my 3 equations in. I need 2 equations to make the equation, or make the graph of a circle. Let me hit zoom 6, and I'm hoping I see an intersection point around negative 1, 3. All right, so there's my circle. looks a little smushed. It looks like an ellipse. It does look like they're intersecting. Maybe that's at -1, 1, 2, 3. It's pretty close. So we sort of have visual confirmation. But let's see if we can get this to intersect. So I'm going to hit second trace, option 5. All right, I do want one of my equations to be the top half of the circle. All right, so I'm going to hit enter. I do not actually care about the bottom half of the circle, so I'm going to hit the down arrow key and go down to the line. I want to see when did the top half of the circle intersect the line. So my second curve needs to be the line. All right, and then I'm going to just guess somewhere around -1. And let's see what pops back up. All right, so I'm getting, even though there's a little bit of a round off error, I am confirming it is -1, 3. All right, thanks so much. Bye.